Through a few things here with you so you can get these notes down, and then we can come to class and we can just talk about it more in depth. So I want you to write these down and maybe leave a little bit of space in between the information that I present today, because there might be a couple more things that we are going to add. So let's first talk about the nervous system as a whole. Remember, we started at the foundational part of psychology in the biological sense of the neuron, right? Then we work our way up. So how do all these neurons create a system? So we'll talk about the central nervous system and the peripheral nervous system. We break it down into two parts. Our central nervous system is literally the brain and the spinal cord. You can see this graphic here. It's the brain and the part that goes down the middle of the body, the brain and the spinal cord. That is the central nervous system. It links all these things like receptors, muscles, and glands. So now I want to talk about these types of neurons. Now these are in the central and peripheral, but I want you to basically understand how and where they work. So we've already talked about motor neurons, but I want to back up a little bit and talk about sensory neurons. Sensory neurons, if they are referred to as sensory neurons or afferent neurons, no, they mean the same thing. Sensory neurons are these neurons that I always think of touch. They're the neurons that receive the message and send it to the brain. So we get the message from, say, a touch on our hand, and it arrives to the brain. It carries the message to the brain and spinal cord, or spinal cord and brain. Motor neurons are those ones, and when we looked at a neuron, we were basically looking at a motor neuron. Motor neurons are in our brain, and these are known as efferent neurons. They take that message and they send it out. It exits our brain to do something with, usually a response of some sort, whether it's speaking or touching or reacting or whatever action or behavior we have. So those carry instructions from the central nervous system to the muscles and glands. And in between one, right there in the spinal cord up to the brain, are what we call interneurons. And these kind of intervene between the two. Sensory neurons are afferent neurons. They take in this information, arrive to the body. Efferent neurons or motor neurons send this information out. They exit the central nervous system and send it out. It's the interneurons that are kind of the liaison, if you will. And we find the interneurons, especially in the spinal cord, going to the brain. So they're kind of like that mediator. They're kind of the messenger from the sensory neurons to the motor neurons. We'll do a little neuron dance, so hopefully I can get some people to join me when I try to help you remember how to keep those all straight. Okay, so let's talk about the peripheral nervous system then. Remember, we have the central nervous system, which is the brain and spinal cord. Then the peripheral nervous system is everything else. You can see this diagram here, the outline of the guy. You can almost imagine where the brain and spinal cord would be on him. That is not part of the peripheral nervous system. The peripheral nervous system is everything on the periphery, everything outside of the brain and spinal cord, okay? So there are two parts of the peripheral nervous system, and this is where I kind of want you to leave a little bit of space, whether it's in the margin of your notes or somewhere, because we're going to diagram this out. So we're going to have the nervous system, we're going to have the central nervous system, and the peripheral nervous system. Then in the peripheral nervous system, we're going to break that down further into two parts, the somatic and the autonomic. The somatic nervous system, think about the word soma. Remember when we talked about soma, it means body? The somatic nervous system is like this voluntary part of our peripheral nervous system. It's the part that we can control. It controls things like our skeletal muscles, and it's voluntary. Means we can move our arms, we can react. I can pick up a pencil, I can push my foot on the brake, I can lift a cup to bring it to my lips. Okay, so this is the somatic nervous system. The autonomic nervous system is automatic, meaning we don't control it. It's involuntary. This is what controls like our glands and our internal organs. So for example, right now, my kidneys are filtering all the stuff out that needs to be taken out of my blood and my body. The kidneys are doing that. I have no control over that. That's part of the peripheral nervous system of the autonomic branch of the peripheral nervous system, the autonomic nervous system. Okay? Oh, I'm going to move over here. Now, remember, I need you to leave a little space because this is going to go even one step further. We've got the central nervous system and the peripheral nervous system. The peripheral nervous system is broken down into autonomic and the somatic. Now, I want you to know that we have one more breakdown in the autonomic nervous system. Remember, autonomic means automatic, so we don't control this. This is involuntary. We have no control over it. There's two breakdowns in the autonomic nervous system, the sympathetic nervous system and the parasympathetic nervous system. So let's start with the sympathetic nervous system. The sympathetic nervous system gets our body up. It arouses us to be prepared for fight or flight. It's an automatic thing that when we need to respond quickly, let's take, that idea of like driving. I have to slam my foot on the brake. I can do that, but at the same time, my body is like going into high alert. My heartbeat is increasing. My blood pressure has increased and my pulse. I'm starting to sweat. My digestion slows. Like I don't think about having to go to the bathroom at that point because I don't need to. So the sympathetic nervous system gets us up and ready, expends that energy to prepare us for anything that we need to accomplish, like that fight or flight. So if you're getting ready for the big game, your sympathetic nervous system is probably getting pretty high up there. Your pupils are dilated. You're looking at everything really, you're highly anticipating because you're excited. You got a lot of energy and you're ready to go. Now, we cannot stay in that state for a long time. Our bodies have got to come back down and lower down. If we have a constant increased heart rate, a constant increased blood pressure, if our pupils are dilated, if we don't have this digestion happening, well, we're probably going to have like a heart attack or like a stroke. Like our bodies cannot stay in that. So naturally, involuntarily, right? We don't control this. Our bodies try to bring us back down. The parasympathetic calms us down. I always think about the parasympathetic system like a paramedic. A paramedic will arrive on scene and try to kind of calm the situation and bring it back to normal as much as possible. So the parasympathetic just does the opposite of what the sympathetic system does because we can't stay in that heightened state of anxiety. Like we can't stay way up there. So it brings us back down. It lowers our blood pressure, it decreases our heart rate, our blood sugars go back to normal levels. Everything kind of kicks back in the way our pancreas works and our digestive system works and all of those things. But we don't get to control this, right? We don't get to control this somatic system or the parasympathetic nervous system, the sympathetic nervous system or the parasympathetic nervous system. So both of these work together, and I want you to put this word in your notes and underline it. It's a good key term. Both of these nervous systems, both the sympathetic and the parasympathetic system, work together in a steady internal state known as homeostasis. You've maybe heard about homeostasis before. One gets us up and the other brings us down, and that balance of like a normal internal state is known as homeostasis. Okay? So there's another graphic here. You can kind of see which is responsible. So the sympathetic arouses us, gets us ready for fight or flight. The parasympathetic calms us, brings us back down. Pupils contract. Our digestion begins to stimulate. Again, all these things that we just kind of talked about. Okay? All right, and so I want to talk real briefly, the last thing, about how the body talks to the brain. Do you see this? Like these are like the interneurons in the central nervous system, right? Well, what we understand is that, for instance, like a reflex is an automatic response, right? So think about like pulling your hand away really fast from a candle or something. We have these knee-jerk reactions, and we don't really control them to a pretty big extent. Thankfully, we can do it quickly, because if we can't, like, we'd really burn our finger over that flame or whatever it is. So we talk about this pain reflex pathway. And so it goes from the sensory neurons to the interneurons. Remember, the interneurons are in our spinal cord up to our brain, and then the motor neurons, and the motor neurons are in our brain, allows us to react and respond, right? So this all can happen without even our thinking about it. This just oftentimes when we're talking about pain, it can just be automatic, and we don't even think about that reaction and that reflex that we have. I think putting your finger over a flame is one of the best ones. You'd pull it back really quick. Well, if it took you so long to think about, oh, this is burning my hand, for you to pull your finger away, I mean, you think fast, but you don't think that fast. Your reflexes are even faster than how fast your brain can respond and react. And that's a good thing, right? If we had to wait for our brain to realize what was going on and then react, we could do a lot of serious damage to our bodies. So that's kind of one of the interesting things, though, when we talk about brain and spinal cord communication. So let's say that we have here, I'll turn this way. Let's say we have a spinal cord injury pretty high up on our spinal cord. All of the sensation, all of the stimulation that we should have, from that point down, we don't have feeling. We don't have that sensation. That stimuli is not getting up to our brain. And so the point of where your spinal cord injury is depends on where you can feel those sensations, those nerves in your body, like in your extremities. If you have a lower spinal cord, it's everything, you can feel everything from that point up on your body. But if you have a high spinal cord injury, well, everything from that point down is you can't feel it. It's a lack of sensation. And so what's really interesting is when we've seen, say, severe injuries in like war or things where people have become amputees, there's something called phantom pain, which our spinal cord tells us, the pain reflex tells us that we shouldn't feel like pain in our leg because we don't have a leg, right? Like it's not there anymore. But what's really interesting is that people will report phantom pain where they have pain, but they don't even have that limb anymore. And that's really amazing. So we know that as much as the brain and spinal cord communicate together, the brain continues to feel things that are really, really quite amazing. Okay, so here's just a few hints. We're about done here. I just want you to remember, I want you to remember things like the central nervous system is in the center of the body, the brain and the spinal cord. The peripheral nervous system is everything on the periphery of the body. Everything but the brain and spinal cord is included in the peripheral nervous system. The somatic, think about the word soma, like body. It's voluntary. Your body voluntarily takes these actions. I move my hand away. I put my foot on the brake. And then the autonomic sounds like automatic. It's involuntary. We don't control things like our heartbeat. Okay? So get these notes down, and then when we come to class, we'll discuss them a little bit further, and I'll have you kind of chart out the way it's all broken down. Okay, till we meet again. Goodbye. I've got to be frigging kidding me.